Hello everyone. Last time, if you remember, we discussed about the electrolysis, meaning of electrolysis. We understood that how electrolysis is different and completely opposite from the synthesis reaction. We have understood the type of electrolytic materials and what are the weak electrolysis, strong electrolyte, all these things we have understood. Now, actually, we are going to get into the main topic of this chapter. What is the electrolysis process? And this how this process is actually exactly opposite of formation of ionic bond, and electrolysis is a redox reaction or not. Let's understand this. So you're seeing over here, it is electrolytical chamber. This one is electrolytical chamber. It could be any non-conducting material that bears a high temperature also, but in this case it is not bearing. Okay. And here it is the water we have taken. Okay, I've shown with a different color, but hope so it conveys the meaning. And let's see this one. These two small cylindrical pipe you're seeing, basically they are electrodes which is connected towards the connected to the battery like this and like this. So suppose this is basically connected to the positive terminal. This is positive terminal, and suppose this is negative terminal. Okay, so what will happen in this case? What this positive and negative means? It going to create potential difference. Going to create potential difference PD. And you know, if you read the in this terminology in the physics, you might have read this. It is a work done to bring a unit positive charge or unit charge once around the closed circuit. Okay, so what is the meaning of this one, that bringing a unit positive charge once around the closed circuit? Basically, what potential difference does? Let's see this one. Suppose this pipe is metallic pipe, basically it is electrodes, so metallic pipe it will be. And there will be free electron over here. So many free electron in this electrode. Okay. So if there is so many free electron, this positive charge will start gaining the electron from here. Okay, when attracting from here, and it will take out all the electrons from here and it will give to this negative terminal. Okay, so here you're gonna find huge number of electrons on the surface of the electrodes, and you're gonna find over here is the absence of electron. So basically it is negatively charged. It will be negatively charged, and this one will be positively charged. So remember the idea. Whenever the absence of electron is there, it gains the positive charge. For example, if you take the hydrogen atom, and hydrogen atom in the nucleus, the proton is there, and around it what revolves electron. So suppose here in the case of proton, that means one positive charge and one negative charge. So total charge is zero. But you just remove the electron, just remove the electron from here. Okay, I'm taking a bigger eraser. Just remove the electron from here. So what are you going to see over here? When you remove the electron, so that means you remove this one. So answer is coming positive. So when you doing the absence of electron, so thing is becoming positive, right? So what will happen in this case? This pipe is going to acquire the positive charge, and this is going to acquire the negative charge. Now keep in the mind, the positive is absence of electron, negative presence of electron. Now see this one. We have taken this water, and in order to do the electrolysis, we need electrolytic substance. So I love the substance, electrolytic substance, which is NaCl. NaCl. Okay, why I like this? Because it is made up of highly positive, electropositive element, metal, and highly electronegative element. You can also take this KCl, also very good, or any other substance which is basically polarized. Okay, so here basically we are dissolving NaCl. I dissolve this NaCl in the water. I can take in the molten state also, but this NaCl is soluble in the water, so why I'll waste so much energy by heating it and then melting it down? So better I will take it in a soluble condition. So this is the solution that you're seeing, mixture of Na and Cl we call electrolytic solution. So what we're gonna call this? We're gonna call this this entire thing is electrolytical solution. I just take the pardon for my bad handwriting. Actually, it's not, but on the this writing pad is going very bad. Okay, now see this one. This NaCl you're seeing over there basically is a polarized ionic bond. Ionic bond, all ionic bonds are polarized. So if you'll dissolve in the polar covalent bond, which is water, So it's going to break down into Na plus and Cl minus. Now see this one, Cl minus. Okay, now just to start, let's start naming this. So this terminal, basically, this is you're seeing over here. This electrode is basically negatively charged. Okay, so we call this cathode, remember. And this one you're seeing over here, which is positively charged, we call this, take the different color, we call this anode. Oh, N left. Anode, we call this anode, we call this anode. Okay, basically it is positively charged. Okay, now see this, what will happen when you dissolve the NaCl, it broken down into Na plus and Cl minus. So what's gonna happen next? When you applying the potential, this free ions will start experiencing force, electrostatic force. Okay, so this basically, this NaCl will try to move towards the negative terminal. So it will start drifting towards the negative terminal, and the Cl will try to go towards the positive terminal because it is negatively charged. So this positive terminal will attract this negative ion, and this positive ion will be attracted towards the negative ion. Okay, this positive ion that you're seeing, we call this, we call cation. Okay, and we call this anion. Okay, one more thing over here. A lot of people get the confusion that this is positive is cation or negative is anion. So in order to remember this one, see this one, cation got the T over here, which looks like a plus sign. Okay, so remember, whenever the cation, it's made of a T which is looking plus, so it will be positive charge. So positively charged ion we call cation, and this negatively charged ion we call anion. Now see this one, what will happen in this case? This positive negative ions, now it's free and it is drifting towards the opposite terminals, opposite charged terminals. So what will happen? Let's start analyzing first in the case of this anode. This chlorine is going towards the anode. Chlorine is drifting towards the anode. Okay. Now, if the chlorine minus sign is there, that means this anion is going towards the anode. Okay. Now you see this, what this positive terminal is doing. It is taking the electron and putting this electron to the cathode. So what will happen, this, if the chlorine will reach over here, the Cl minus will reach over here. If the Cl minus will reach this electrode, it's going to lose the electron. It's going to lose the electron. And if it is losing the electron, now it is already having one more electron. So if it is losing the electron, it will become Cl. Okay, suppose not one chlorine is going, chlorine is going. So two chlorine will lose a two electron and it will become Cl2Cl. Actually, this chlorine is a nascent element. So Cl plus Cl will combine and will form Cl2. So you're going to see that Cl2 is the gas is coming out from this electrode. Okay, this positive terminal. So always remember that negative ion always moves towards the anode, which is positively charged. Okay, let's see this one, next one. uh, now you see over here, you need to pay attention that basically chlorine is losing electron. It is losing electron, and if it is losing electron, the loss of electron in the process we call oxidation. We call oxidation. So loss of electron is oxidation. So that means the chlorine is going through the process of oxidation. So we can say that the process of oxidation happens here at the anode. The process of oxidation happens at the anode. Now let's see what is happening at the cathode side. This is cation, basically Na is there, which is positively charged, will be attracted towards the negative cathode. So it will start drifting towards the cathode. And if Na is going towards the uh, this cathode, remember the cathode has huge number of electrons. Okay, and Na is not having electron. So what will happen? This Na will gain the electron and will become Na plus. And this is a metal, so it will stick over here. It will stick over the electrodes. Okay. So here you can see this is complete simple idea. Completely simple idea is that it is gaining electron. So whenever any metal or any ion gains electron, basically it is called reduction. We call this reduction. So sodium basically is going through the reduction, and where the reduction process happens, it happens at the cathode, because cathode contains a huge number of electrons, free electrons. So sodium is gaining the electron from the surface of this cathode. Okay, so it is going through the reduction, and at the anode what is happening? Oxidation, basically chlorine going through the oxidation. So reduction plus oxidation, we call this reaction is basically, this reaction is redox reaction. So hope you understood what is happening at the cathode side, what is happening at the anode side, and why the dissociation of NaCl through the electricity, basically electrolysis of NaCl, is a redox reaction. So what happens after the electrolysis? This NaCl will change into Na plus Cl2. This equation is not balanced, you can balance this. Okay, so it will form basically 2Na and Cl2. This chlorine gas will go from here, and this basically sodium will stick over here because it is metallic, so it's not going to form the any gaseous formation like Na2. It is not possible because they are both are electropositive, so it is having no tendency to give the electron, so that's why they don't form the covalent bond. Hope you understood this. Okay, class. Now see, what I was saying is the formation or basically electrolysis. Electrolysis is just the enter process of this formation of ion bond. Formation of ionic bond. How? See, with a simple idea. If you're seeing this electrolysis and the formation of ionic bond, first let's understand the formation of ionic bond. What happens? Formation of ionic bond, that Na is the metal, and the metal has the tendency to lose the electron, so it is electropositive. When it is losing electron, it is becoming Na plus, and Cl is having the tendency to gain the electron. So when it is gaining, it is becoming Cl minus, and this Na plus Cl minus together they create ionic bond. They create ionic bond. But over here you must notice the sodium is basically losing electron. Okay, so it is going through the process of oxidation. But here you pay attention. Sodium is going through the process of reduction in the electrolysis. In this case, sodium is going through the process of reduction. So you're seeing this in the electrolysis is just happening opposite of the formation of ionic bond, where the metal losing the electron, here the metal gaining the electron, which is completely opposite. Okay, now here you can see at the same time chlorine is gaining the same electron which is being lost by the sodium. So here the chlorine is gaining electron in the formation of ionic bond. So basically they are going through the reduction. Okay, and here you can see in the electrolysis chlorine is losing electron, which is going through the process of oxidation. So process here is completely opposite. Metal is going through the reduction and non-metal is going through the oxidation. As we have seen in the formation of ionic bond, metal is going through the oxidation and non-metal is going through the reduction. So that's why electrolysis is just opposite of formation of ionic bond. But yeah, in the formation of ionic bond, there is nothing happens, just metal comes into contact with the non-metal and they just normally react without any electricity, or we don't take any electricity from the formation of ionic bond. But in the case of electrolysis, if you'll see, we are doing with the help of electricity, and basically in the formation of ionic bond, the bond is forming. The bond is forming in the formation of ionic bond. But in the formation of electrolysis, what will happen? The breaking of bond is happening. That Na, you can see over here, that Na is breaking down and forming Na and Cl2. So hope so you have understood the idea that electrolysis is a redox reaction, but just in opposite way the formation of ionic bond. And what is happening at the cathode? Always remember the metal reaches at the cathode, okay, and the non-metal reaches at the anode. Why? Because they are negative charge and anode is the positive, so it will go over here and lose the electron. So this is the idea basically. And let's see this one, but there is a very specific kind of material, that is hydrogen. Hydrogen is only a non-metal. Remember this one, that's very important. Only non-metal that travels towards the cathode. Why? Just take the example. If you're dissolving HCl, suppose, so it's going to form H plus and Cl minus. So Cl minus will reach towards the positive, which is anode, but H plus will reach towards the cathode because it is electropositive charge it has. Okay, so if it is reaching the cathode, so what will happen? Suppose 2H is going, so it will create H2. So only non-metallic gas that comes from, okay, by the way, the gases are basically the compound in normal condition, non-metallic, it will be there. Okay, so only non-metallic gas that comes out from the anode, which is just hydrogen. Remember, this is very important. Except hydrogen, all the metal goes at the cathode, and all the non-metal goes at the anode. Okay, always you'll find non-metal, it will always be there at the anode. Okay, but one non-metal is there, that is the exception, which is hydrogen goes over there because hydrogen uh, behaves more electropositive comparison to, it behaves like uh, tendency to create a positive ion. That's why it goes towards this. Okay, so hope so you'll keep in this mind, and from this process we can easily understand the characteristics of electrolysis. So let's discuss one by one. We have understood that how this ion moves towards which terminal, what happens at each terminal, and what kind of metal or non-metal goes towards which terminals. So let's see one by one. I'm going to write down the characteristics over here. Okay. Okay, now you have understood this process of electrolysis. Now we're going to understand about the characteristics of the electrolysis. So basically the characteristic of electrolysis is nothing but the whatever the process we have understood, just we have to write down by making some notable point. Okay, so you're seeing the first point, the passage of electricity through an electrolyte is caused by the ion basically. Okay, so whatever the electricity flow in the electrolysis, like we can take the electrolytical chamber. Okay, we can take the electrolytical chamber over here, and we will put the two terminals. One is the positive, another one is negative. So you have seen this sodium and chlorine. Sodium is moving towards this one, and chlorine is going towards this one. So because of this Na plus and Cl minus, it was possible that electricity was flowing. Okay, so basically our basic idea from here is because of the free ions, because of the electrolytes, basically electricity is flowing in the electrolytical chamber. Okay, now see this one, positively charged ion moves towards the cathode. We have understood this one, and if it is moving towards the cathode, what they do, they do the process of reduction. Okay, and negatively charged ion moves toward the anode, and they do the process of oxidation. Okay, hope you understood this in a very detail. We have explained this. Okay, now the electron lost at the anode, equal number of electron is gained. Means what? If the sodium is gaining one electron over here, like we have seen in the process of electrolysis, when the sodium is gaining the electron one, so chlorine will also lose the one electron. So loss of electron will be equals to gain of electron. Now here we have not done the two. Now do the over here. So you can see in the equation I've done. So you're seeing this, if the two chlorine is losing the electron, then two sodium will gain the electron and will form this positive will not come. This will form Na. Okay. So number of electron loss at the anode will be equals to the number of electrons loss at the anode will be equals to the number of electrons gain at the cathode. Okay, CGC. Okay, electrolysis products are formed at the anode and cathode since the exchange of electrons occur at the electrodes. We have understood, but here it is saying surface. Always remember whatever the charges anybody is having, any type of point object or the mass object is having, so the charges will always be on the surface, not inside. And if it is charges always in the surface, that's why if the metal is going, sodium is going and taking the electrons from the electrodes. So that's why they stick on the surface of the metal. Always remember, we call this process of electroplating. So if you take any metal and you suppose you're taking Fe, okay, and you'll take this copper positive. Okay, so you have taken this Fe, and this copper will always will go towards the this cathode and will stick. So it will make a layer. It will create a layer on this Fe. So that is what we call electroplating. So remember this one, charge is always on the surface. Now this is the case of hydrogen. The hydrogen gas and the metal will liberate at the cathode. Remember, basically metal never liberates, only hydrogen liberates. So this word is for the hydrogen. Metal will stick on the cathode. Okay. Hence, they are called electropositive element. In contrast, non-metals are released at the anode. Okay, they are called electronegative elements. Whatever the non-metal will go over there, they will create gas. Okay, so it is right to say they will be released over there. Okay, here the process of electrolysis is a redox reaction, and the electrolysis is caused by the direct current. This is, we have understood why it is a redox reaction, but this is new point. We can do only by DC. Why? Now the idea is very simple. If you see the AC current, alternating current, the alternating current problem is their direction is changing. So suppose if I'm taking a terminal, two terminal, okay, and take the example of sodium plus. So sodium is seeing this negative terminal and this is positive. And suppose I apply the AC. AC current, when what is the problem with the AC current is AC changes the terminal. This negative that you're seeing, within a second it will turn into positive and this will turn into negative. So for example, just take this, suppose sodium is started traveling towards this negative terminal, because negative and sodium is positive, so this sodium will go towards the negative. But due to the AC current, terminal will change and this negative will become positive and this positive will become negative. So instead of going towards this, sodium will start moving towards this, and when the sodium will start moving towards here, then again it will change into positive, because you can see AC goes like this, again change into positive. One time it was positive, then negative, now negative will be positive. So this will be again will be positive and Na will be repel, it will go like this. So what will happen, instead of drifting towards a specific direction, Na will start doing vibration like this. It will go like this. Same will happen with the chlorine also, it will start doing the vibration. So what will happen, molecule will not move, instead of that it will start doing the vibration like this. Okay, so that's why with the AC we can't do the electrolysis process, but with the DC, because DC, the criteria of DC is it keeps the current in a same direction, or better to say that DC we will take, but the constant DC will take. That means the like magnitude of the current is not changing. In the AC, magnitude of the current also varies. Okay, you can see the maximum current over here, then minimum current, then negative maximum, then minimum, then negative maximum. So magnitude of the current is also getting differentiated. So in this case, what will happen if the magnitude is changing? So deposition of the metal will be uneven. Okay, if the current is increasing so much, so metal will start going towards the cathode so much. If you decrease the current, then the metal will go very fumble to go towards the cathode. So that's why the deposition of the metal at the cathode will be uneven. That's why we just not need to keep the direct current, but also the current has to be slow and constant. Remember this one. So these are the things that we have learned in this lecture. The direction of the current, where it will go, and we have understood the direction of the ions also, and we have understood that electrolysis is the process of redox reaction. Okay, thank you so much class.